What is a binary search tree? You might have already heard of the tree data structure. It's a way to organize data in a hierarchical way. A tree has a root with child nodes. Nodes without any children are called leaves. The main differentiating characteristic of a binary tree is that the number of children a node can have is limited to 2. Because there's only 2 children, we classify them as either a left child or a right child. A binary search tree is a special type of binary tree that follows this rule. The value stored in the left child and all of its descendants is always less than the value of the parent node, and the value stored in the right child is always greater than the value stored in the parent node. In this example, 5 is the parent node. Seeing as 3 is less than 5, it will be stored in the left child. When we insert 8, it will be stored as the right child, as 8 is greater than 5. Thanks to this hierarchy being enforced without exception, it's possible to search the tree quickly, using a binary search without ever having to backtrack. Let's say we want to find the node containing 30 in this binary search tree. We start by comparing 30 to 20. 30 is greater than 20, and we therefore look to the right child. We once again make another comparison, this time between 30 and 32. Given that 30 is less than 32, we look to the left child, where we find 27. Seeing as 30 is greater than 27, we look to the right child, where we find 30. What about adding values then? Just as in a search, we trace the tree until we find the correct position for the new node. In an unbalanced tree, the new node will always be added as a leaf. Consequently, the average time complexity for a search or an insertion is O of log n. But the worst case time complexity for a search is O of n, where n is the height of a tree. This becomes especially problematic when the tree is severely unbalanced, as in this example. There are several strategies that can be used to avoid this problem. One of them is called an AVL. Watch the video on AVL trees to learn more about how.